Hey, what's going on, guys? Let's do this problem right here. The first question is asking, a block attached to a spring is set into vertical oscillation with an amplitude of 6 centimeter and a frequency of 2 hertz. So we have amplitude, frequency, and t is equal to 0 second. The block is below the equilibrium, and is moving downwards. So downwards at 28 centimeter per second. Assume that the displacement from equilibrium is given by this equation right here, and with y is y positive upwards. So calculate the phase angle phi. So let's see how we can calculate. So we have the amplitude for this equation, and also we have omega we don't have, but we can use 2 phi. We have frequency, and time is 0 phi, and they have also given the velocity. So let's derive the velocity equation from this one. If we have y is equal to ym cos omega t plus phi, the derivative of this one is going to be the velocity equation. So velocity is going to be derivative. This one gives us negative ym omega, and we are going to have sine omega t plus phi, and we have t is equal to 0, so that will get rid of these things, because t is equal to 0, and then we have left with sine phi, so that makes everything simple. And we have this one acting downwards, so it's going to be negative. It's given in centimeter per second. I have to convert into meter per second, and that's going to be negative 0.28 is equal to negative. So here amplitude is 6 centimeter. I have to convert into meter, 0.06, right? And then we have omega. I can put 2 phi f instead of omega. 2 phi times the frequency, that is 2 hertz. So 2.00. Then we have time. I'm doing this omega right here, this one. Then we have sine, and the time is 0, so I get rid of this thing, and we only left with phi right here. So let's rearrange this equation. So sine phi is going to be equal to, if I simplify this one, so we have 0.28 on the top, and if we simplify this one, this gives us negative 0.2405, right? Because 6 times 2, 1, 2 times 2, 0.24, and that's how I got this one right here, and 5. Then we have to find the phi, and if you plug it in the calculator, that gives you phi is equal to, this is going to be sine inverse, this value is going to be the phi. So sine inverse this value, if you get, you will get, and for this one you will get a positive number, because negative cancel, and you will get a positive number. This means we know that sine is positive in the first and second quadrant. So this means this is going to have two values. We don't know in which quadrant it is. So we are going to find out, but we have to put both of the values. So first value is going to be 0.38047, or 5 minus 0.38047. Since we are not sure which quadrant it is, because 1, 2, both of them are possible. So let's take this equation, the displacement equation, and if I pick up this equation, let's use a different color right here. Y is equal to ym cos omega t plus phi. If I pick up this equation, we know that time is 0, so we will get rid of this thing right here. We are going to be left up with cos phi, and this one is below the equilibrium position. Y is below this, so it's negative. Divided by ym is going to be negative. So we know that cos is negative. So cos is only negative in the second, like old silver tea cup. So we know that cos is negative only in the second and third quadrant. And in the first one we found out this should be between first and second quadrant. So here both have second quadrant common, so the answer is going to be second quadrant is going to be the right answer. So if you deduct this one from this 5 minus this one, this gives you, this value comes out to be 2.76112 radians, and that's going to be the value. So that is the answer right here. So that is the answer for this question. And the next question is asking, a transverse sinusoidal wave traveling along a string has a speed of 130 meter per second and an angular wave frequency of 3.5 times 10 to the power of radians per second. So they have given the omega, that is omega is equal to 3.50 times 10 to the power of 3 radians per second. And also they have given the speed, that is v is equal to 130 meter per second. And they are asking to find the k. So that is what angular wave number means. So they are asking to find the k. So we know that k is equal to 2 pi over lambda, but we can relate that equation with v. V is equal to f lambda, right? V is equal to f lambda. Therefore, lambda is going to be equal to v over f. And if I plug this one into this equation, k is equal to 2 pi over v over f. This f will flip to the top, and that's going to be 2 pi f over v. We know that 2 pi f is equal to omega. Therefore, k is going to be equal to omega over v. We know the omega, that's 3.50 times 10 to the power of 3. 3.50 times 10 to the power of 3 divided by 130 radians per second over meter per second, and that's going to give us 26.9231 radians per meter. So that is this answer right here. Also, if you look at this units right here, that gives a clue, because if you look at the angular frequency, that's radians per second, and if you look at this velocity, that's 130 meter per second, and we have to get the unit, the radians per meter, right? And if you divide this one by this one, you get the same unit. So that's kind of gives you the clue, but you have to know all these equations, and that's how it's done. I hope you guys like this video. See you next time.